Welcome back to Golang for Devs. Let's talk about interfaces. So just like in other languages, interfaces are a way to define a common set of behaviors for an object or a type. And you can define an interface in Go using similar syntax that you would use for a struct, with all the methods required for implementing the interface listed in the body. One nuance with interfaces in Go specifically is that you can't specify fields like you can in some other languages. So they're only for defining method sets. So here we have a printer interface, and to implement the interface, any type would just need a print method attached to it that matches this definition. You can also have unexported methods in a interface definition, with the main difference being that you can only access the unexported method from the same package. But functionally, this means that no other packages can implement the interface. Even if you add this method to your type, Go won't recognize that it's actually implementing the interface because it's unexported and in a different package. And just like with structs, you can embed interfaces into other interfaces by listing the interface you want to embed, along with any additional methods. So all this does is combine the methods that are required to implement the interface. So if I want to implement fancy printer, I would need a print fancy method, but also a print method from the printer. All right, so let's implement the printer interface with a print method. So first you define any type, in this case, a struct. Then you attach the methods that you need to implement the interface. And this right here is the biggest difference between interfaces in Go and interfaces in other languages. In Go, interfaces are implemented implicitly, meaning you don't need to do something like implement printer. Totally unnecessary. It's 100% less readable and a little bit annoying, but the compiler's got your back, so you don't need to worry about it too much. And I haven't covered this in this series yet, but Go lets you make custom types based on any of the built-in types in Go. So for example, I can have a custom int that behaves the exact same as a regular int, but I can also attach my own custom methods to it, meaning the type can also implement the printer interface. This isn't overly useful all the time, but it's still interesting. All right, there's also a small gotcha you should know about when you're implementing interfaces. So when you define an interface, you only provide the general method body. There's nothing saying if the actual method implementation should be a value receiver or a pointer receiver. So it can be either. And if you don't know what those are, you should check out my previous video on structs, and I'll throw the link in the description. So if I have a struct type, I can implement the interface using a value receiver or a pointer receiver using the star. But which one you choose to use will change how you can actually use the interface. So if I am using the value receiver, both a direct value instance and a pointer instance would implement the dog interface. But if I use a pointer receiver, only the pointer instance will be considered an implementation of the dog interface by the compiler. So let's say I have another function that accepts a dog as an argument. Then I could call that function and pass in either of the variables. But if I'm using a pointer receiver to implement the interface, then only a pointer satisfies the interface, meaning passing a value instance to a function expecting a dog will throw a compiler error. So to fix that, you would have to use a value receiver instead. To make this even more confusing, you can still call the bark method from the value instance, even if a pointer receiver is used, because Go in the background will take the address of the value and use that to call the method. So to sum that up, if you use a pointer receiver to implement an interface, you must use a pointer instance when you're working with the interface type. And if you want more videos explaining confusing junk like this, then hit the subscribe button. The same rule applies if you're embedding structs into other structs. So if you have a generic interface, an inner struct that you are embedding, and the inner struct implements the interface using a pointer receiver, then you embed the inner struct type into an outer struct type. The outer struct will only implement the I interface if you're using a pointer instance, not a value instance. So the gotcha with using a pointer receiver trickles up through the embedding. So other than those complicated rules, Go is pretty flexible when it comes to how a value that implements an interface is represented in the type system. This all confused me at first, so I'll try to do a simple example. So let's say I have a cat interface with one method and a cat struct that implements the interface. Then let's say I have a function that needs to return an instance of a cat interface. There are a few ways to actually create a cat interface instance to return. First, you can just use a type that implements the cat interface directly. So I can have an instance of the cat struct and return that directly. So internally, Go will auto-convert the cat struct instance into a cat interface instance. So even though you're returning the struct type, the interface type comes out of the function. You can also use explicit type conversion if you need to. So I can make a cat interface instance directly by converting a cat struct instance. And then I can return the cat interface directly. And this is pretty similar, but you can directly use an explicit type. So I'm creating a cat interface variable using an instance of a cat struct. And this works because cat struct implements cat interface. And then obviously you can return the cat interface. Okay, yet another gotcha comes up when you want to convert an interface instance into an instance of any type. So like before, we can get an instance of a cat interface using regular type conversion from a cat struct into a cat interface. So type conversion works when you're going from type to interface. But what if you want to go the other way, from interface to type? If you try to convert the cat interface instance into a cat struct using regular type conversion, you'll hit a compiler error. Even though the statements are right next to each other, the Go compiler isn't smart enough to verify that the cat interface is in fact a cat struct underneath at compile time. Instead, you need to do runtime type assertion with this dot notation, which unfortunately has very similar syntax to regular type conversion. So this works, but it may also panic. So you need to handle that case if you're doing this. Okay, it's also super important to understand how Go stores interface instances internally because it explains some more confusing gotchas. So an instance of an interface type conceptually stores two things. First is the type metadata, which includes the actual interface type, which would be the cat interface in our example, and the concrete type of the value, which would be the cat struct in our example. Then there's the actual data, which stores the concrete value or a pointer to the concrete value in memory. So in our example, it would be a pointer to the cat struct instance in memory. But Go also has the concept of an empty interface. Internally, the only difference is that the type metadata doesn't store the interface type because it's an empty interface. It only stores the concrete type of the value. So you can think of an empty interface as a container that can hold any data of any type. So it's called empty because the interface has no methods, not because the interface instance is actually empty, which is confusing. So empty interfaces are usually just used as a generic type. So if I need to pass a value to a function and it can be of any type, then you can use the empty interface definition as the type. And since generics were introduced in Go 1.18, you can use the any type instead of writing out interface, but it's basically the exact same thing. So now that you know how interfaces are represented internally, I can explain a very common error handling gotcha. So the error type in Go is a built-in interface type with one method. And it's done this way so you can have your own custom error types that implement the error interface. So let's say I have a function f that returns an error type. If no error occurs, I create a nil pointer of my custom error type and then return it. But as we know, interfaces in Go store two things, the type metadata and the actual data. So when you return and Go auto-converts the pointer to a struct type into the interface type, it stores the myError struct type in the type metadata as the concrete type, and it stores a nil pointer in the data part as the actual data. So you think you're returning a nil error here, but what you're actually returning is a non-nil interface instance that holds a nil pointer. So when you check the error that's returned from the function, it will look like there's an error when there was none. And the fix is super simple for this. You just need to return nil instead. And that's enough complexity for one video, I think. Overall, once you get over the nuances around interfaces, they're a super important and super useful tool in Go. If you want to see any of the code or diagrams from this video, the link is in the description. And if you found this video helpful, don't forget to give it a thumbs up and subscribe. As always, keep breathing, keep building, and I'll see you next time. Peace out.